All right, so we're going to look at the volume of any prism. So the volume of any prism is given by the cross-sectional area multiplied by the height. So imagine we had some area that's sort of in two dimensions at the moment. It's a very irregular shape, as you can see. So knowing the area of that doesn't really have a formula to it. But what we do know is if we do know the cross-sectional area, which is this sort of base, if we multiply that by the height, that'll give us the volume of that prism. So let's look at an example here. If we were to say that this cross-sectional area, if we were told that it was 20 centimeters squared, and we were told that the height was 3, so now we're essentially extruding it into the third dimension. So it goes from being two dimensions to being in three dimensions. So let's imagine that this prism has a height of 3 centimeters. Well, the volume says it's the cross-sectional area multiplied by the height. So it's going to be 20 multiplied by 3. So 20 centimeters squared multiplied by 3 centimeters gives us 60 centimeters cubed. And that's basically how you find the volume of any prism. Now, I just wanted to make one other point, which is that it's the cross-sectional area. Strictly speaking, it's the uniform cross-sectional area. Now, what that means is you can see this green plane down the bottom here is what's called a uniform cross-section. And that's because when we cut it in that direction, we get the same cross-sectional shape the whole way through, as you'll see. So hopefully if I move that, you can see that the shape that is on the green plane would always be that shape that we had at the base there. Now we could hypothetically take a cross-section sort of from the side. That wouldn't be a uniform cross-section because you'd be getting different values. You'd be getting different sort of shapes on the pink line, right? So if we were to sort of put it there, as that pink line takes a cross section, we're going to get different two-dimensional shapes on that pink plane. So when we say cross-sectional area, we really mean uniform cross-sectional area, which would be this green one. So it's as simple as taking the area of the base and multiplying by the height. That works for cylinders because cylinders are circular prisms, essentially. Rectangular prisms, obviously, triangular prisms. Is there any I'm missing? Other kinds of prisms? I think that's it. I think they're the main ones. So this is sort of generally true for all prisms. So hopefully you find that useful. Here is a problem you can try. See if you can work backwards a little bit. So the volume of some prism is 235 centimeters cubed. If the cross-sectional area is 17 centimeters squared, determine the height of the prism. So just using that rule we had just before, see if you can set up the equation and see if you can solve for the height of the prism. So good luck with what you're doing, and hopefully that was helpful, and I'll talk to you soon.